Today, we're diving into some really fascinating research that could totally change how we predict one of nature's most destructive threats, flash floods. It's a story about how a really clever tweak to artificial intelligence could give communities, especially in flood-prone areas like Thailand, a critical head start. We're talking about a change that could literally save lives.
All right, so to really get why this research is such a game changer, we first need to understand the core challenge. What is it that makes predicting these sudden, intense floods so incredibly difficult? So let's head to southern Thailand, to the Thale Sap Songkhla Basin. In this part of the world, the monsoon season isn't just about rain, it's about a constant, looming threat of devastating floods. For the people who live here, getting an accurate flood warning isn't just some nice-to-have piece of information, it's a lifeline.
And that right there is the heart of the problem. You see, the most dangerous floods are the flash floods, the ones that seem to come out of nowhere. And the thing is, as this research points out, our traditional forecasting models, they just can't keep up.
This is where we start to look at some new tech. Scientists are turning to a super powerful form of AI, machine learning, and they're asking a really critical question. Can it see the patterns that humans and our older models are missing?
But here's the catch. Even the most powerful AI has a weakness, kind of like an Achilles heel. And to really get the breakthrough in this paper, we have to talk about a huge challenge in machine learning, something called imbalance data.
Okay, take a look at this. This is the actual data the AI has to learn from. See all those orange dots just packed together at the bottom? Those are all the normal, everyday river flows. And then, see those few red dots way up at the top? Those are the rare, dangerous floods. The AI sees thousands of normal days, but almost no floods at all.
In fact, in their entire dataset of over 1,400 points, there were only 8 instances of high-flow events. Just 8. I mean, let that sink in for a second. That is a massive imbalance.
This exact scenario is called an imbalanced data set, and believe me, it is a huge problem for AI. Why? Well, because it basically teaches the model to be an expert on what's common while leaving it almost totally clueless about what's rare, but also what's critically important.
You know, here's the perfect way to think about it. Imagine you're trying to teach an AI to recognize a lion, but you only show it one single photo of a lion and a million photos of house cats. What's going to happen? The AI will get amazing at spotting cats, but it'll probably think a lion is just a really big, kind of funny-looking house cat. That's exactly the problem we're up against. So how in the world do you fix this? How do you make the AI pay attention to the lions, or in our case, the floods? Well, the answer is this really clever set of techniques called resampling.
At its core, resampling is all about digitally rebalancing your data. It's a strategy that data scientists use to make sure that those rare, super important events get the attention from the algorithm that they absolutely deserve.
And you can do this in 2 main ways. First, there's oversampling, where you basically make more copies of the rare data, our lions. Or you can do undersampling, where you just get rid of some of the really common data, our house cats.
And this visual just says it all. On the left, you've got that original lopsided data we started with. But on the right, after using a popular oversampling technique called SMOTE, bam, the data is completely balanced. And what's really cool about SMOTE is that it doesn't just copy the flood data, it actually creates new, believable examples that are similar, giving the AI a way richer, more diverse set of high-flow events to learn from.
Okay, but this is where things get really interesting. The true breakthrough here wasn't just about balancing the data. It was about how they decided to use both the original data and the newly balanced set.
So you might be thinking, great, problem solved, right? Did this perfectly balanced data automatically create a perfect flood predictor?
And the answer was actually no, not always. For some of the AI models, using only the new balanced data actually made their overall predictions a little bit worse. Why? Well, by focusing so much on the rare floods, they kind of lost some of their expertise in predicting the much more common normal flow days. The real genius moment here was creating a hybrid strategy that used the best of both worlds.
They called it the org resampling strategy, and it is just brilliant in its simplicity. So here's how it works. First, for predicting normal low-flow days, you use the original data. I mean, it's already an expert on that. Second, for predicting those rare high-flow floods, you switch over to the new balanced data. And third,
You combine those two specialized predictions into one super accurate forecast.
And the results? They were absolutely stunning. Just look at this chart. This shows the accuracy for one specific type of AI called a Support Vector Regression model, or SVR. On the left, you see how it did with just the original data. And on the right, that's its performance using the new hybrid strategy. I mean, the improvement isn't just noticeable, it's a massive jump.
How massive? For that one SVR model, this hybrid approach boosted the forecasting accuracy by over 22%. Now, that is not just a number on a chart. In the world of disaster prediction, a 22% improvement is a monumental leap forward. It means a much, much more reliable warning system. So, let's zoom out. What does all of this really mean for trying to forecast a safer future for all of us?
Okay, let's boil it down to the key takeaways. 1. This data imbalance thing is a huge roadblock for AI when it's trying to predict rare events. 2. Resampling techniques can totally level that playing field. But 3, and this is the most crucial part, a hybrid approach that lets each data set do what it does best gives you the most powerful forecast. And you know what the best part is? This whole framework could be adapted to help predict floods in other river basins all over the world.
And this brings us right back to the people on the ground. Because at the end of the day, a 22% improvement in accuracy is so much more than a better model. It means more time for families to prepare, more time to get to safety, and more time to protect what matters most.
You know, this research really gives us a blueprint for teaching AI to focus on those rare but critical events that can change our lives in an instant. If we can apply this smart, hybrid approach to floods, what's next? Earthquakes, financial crashes, maybe even epidemic outbreaks? It really makes you wonder, what other impossible problems are suddenly within our reach?